Welcome to Machine Solutions Minutes. My name is Brian Beam, and today I would like to talk about a solution for creating end-to-end or face-to-face or butt welds between two tubes. Our Model 420B is a thermal bonder platform in which two half-round heated dies come together to deliver heat to the materials while simultaneously compressing the materials together to create a much more efficient and strong joint. The 420B features completely automated operation in which the materials are held by two pneumatic grips and the compression is performed by a pneumatic cylinder. Looking at some of the settings of the 420B, it's important to note that the grips themselves should not be gripping the material so hard that it pinches the mandrel within. This will prevent the materials from sliding together during the axial compression phase. So we typically set that as low as possible until you get enough surface friction that it holds one material still while holding the other material and sliding it against the other. There's the die head pressure. Typically that's a nominal setting of about 30 PSI. Sometimes you want a higher pressure, sometimes you want a lower pressure to allow the materials to soften and the material to knit together before those die heads become fully compressed around it. The heat duration is simply the amount of time that the die heads are in contact with the materials. The cool duration is the amount of time that the cooling air will reduce the temperature of the bonded materials after the die heads have opened. The compression distance is the amount or distance that the materials will be pushed together. So let's take a look at the process overall. What you want to do is assemble your materials over a coated stainless steel mandrel. Push the two materials together and then cover the junction with a heat shrinkable sleeve such as FEP, PET, or polyolefin. This is important. The next step is to shrink the sleeve using a hot air station so that what you can do is measure the diameter of the outer sleeve so that you can size the die heads properly. So once you pre-shrink that sleeve, measure the diameter of the sleeve over the joint, you then bore the die heads 0.003 smaller. You want an interference fit between the die heads and the outside of the heat shrink. This will ensure efficient transfer of the heat to the materials. Once this is complete, you will position your products between the die heads and between the grip heads. Once the cycle is activated, the grip heads will grasp each tube. The die heads will then come together to deliver the heat to the material. After the compression delay times out, one grip head will actually move towards the other and compress the materials. This compression distance is typically very small, on the order of 5 to 7 thousandths. It does not take a lot of compression to get those materials to flow together and create a strong joint. After the heat duration, the cooling jet comes on and cools the materials down to ambient temperature, and then the grip heads will open and release the materials so they can be removed, and the heat shrink sleeve is then removed from the junction. So that completes the overview of the 420B thermal bonder butt joint solution. Thank you for your time.